In this fourth video, we're going to look at how we can use those physical properties that were mentioned in video 3 and how we can separate mixtures based on some of those different physical properties. So physical properties can be used to identify material. I mentioned that with density, how they're all unique, and you can look up the density once you've calculated it to find out what material you have if it is unknown to you. But you can also choose certain materials for certain reasons. You wouldn't want to use certain like metals, for example, for cooking, because you wouldn't want to burn someone's hand because of how they conduct heat. But you would want to use them for the pans for cooking because you want the heat to get to the food. So you can use certain materials for certain reasons depending on the properties that it has. Now, we need to be able to separate mixtures, and we have a few different ways that we can do this, and it kind of depends on the size of the particles. So back to kind of the suspensions, the colloids, or the solutions. So depending on the size of the particles, some of these will work better than others. So filtering. Filtering is a process that separates the materials based on how big the particles are. For example, when you make coffee, you have something kind of like this, only you're putting water through coffee filter, through the coffee grounds, and then you're getting the coffee through on the other side. The coffee grounds, though, don't go through the coffee filter. This is how people in some countries actually get clean water. They take dirty, gross water, and they have to put it through, cheesecloth, through filters, and get cleaner water out on the other side, and they go through several filtering processes like that. Usually the filter, there's different types of filters. Some allow larger particles to go through. Some are very, very tightly put together so that only very small particles can go through. So filtering is a way to separate larger particles from bigger ones. You've done this in the kitchen when you filter out the water from your macaroni, okay, when you're making macaroni and cheese. Distillation is a process that you maybe don't do very often, but it is an incredibly important process. But this is how you can separate what is dissolved in a solution and separate the water from those dissolved particles. So for example, salt water. We use salt water a lot from the ocean. That's how we get sea salts and things like that. Well, how do you get the salt from the salt water? How do you separate those? And you do that by distillation. Water and salt boil at 2 different temperatures. And so what you do is you take the salt water and you start to boil it, heat it up. The water is going to evaporate faster or start to boil into a gas. And just really quick, if I were to draw that. And then what they do is they have tubes that they will allow the hot water as steam will come up through that. And then as it gets over here, it gets away from the heat, it turns back into water droplets, and they can collect the water over in this container. And eventually over here what they're going to have is just the salt particles that are left over. So this is how you can convert seawater into fresh water for drinking. You're also going to need to be able to recognize physical changes. We're going to get into chemical changes, so right now that might be kind of hard to do, but when we talk about the difference between physical and chemical changes, it will be a little easier to recognize one from the other. But a physical change is when you are going to change your substance, but the material actually remains the same. So chemically you're not altering what type of matter you have, but you may just be altering how much of it you have, for instance. Some changes can be reversed, some physical changes. So for instance, when you melt ice, you take an ice cube, you can melt it into water, you can put that water back into your ice cube tray, you can refreeze it. You can braid and unbraid hair. Those are things that you can reverse, but there are some physical changes that you cannot reverse. So let's say that you're cooking and you have to slice a tomato, or you have to cut celery, or whatever that might be. Once you've cut it, it's cut. It's still a tomato, it's still a piece of celery, but now they're different sizes and you have 2 of them instead of 1 of them. So it's a physical change because you haven't altered what your material is. It is still a tomato, but you have altered the size of it. So chemical changes and physical changes are going to be very important to chemists because we need to be able to tell a chemical change when it's happened in a balanced equation. So we need to understand and recognize those now so that we get into future chemistry problems. We understand what those are, and we'll talk about chemical changes and chemical properties in our next video.